general chemistry classroom because it's fun to get my undergraduate students excited about chemistry, get them all jazzed about the materials we're learning. But I realized that I was kind of missing out on the kids that were underneath 18 years old. And so with the outreach program, I was able to connect with them, but I wanted to do something else, something more. And so I decided to partner with Penguin, and specifically an imprint called Philomel, and we decided to come out with a 7-book series. And so 4 of them are out already, and then 2 come out next May, and then the next ones come out after that. But let me kind of tell you just a little bit about them, and then I'm going to do a couple experiments for you. So with the fiction series, what I wanted to do was write a story, something that was fun and interesting, but make science come alive and have fun with it. And so what I decided to do is write this Kate the Chemist series. And so what it is there's this little Kate the Chemist, she's 10 years old, and she goes around her neighborhood and she solves her problems with her best friend Birdie, who's also on the cover of all these. There's Birdie right there. Let me show you. There's Birdie. And that's Kate right there. And so they're 10 years old, they're 5th graders, and they go around their neighborhood and they solve problems using science. And at the end of the day, they do some science explosions as well, because obviously I'm a chemist, I've got to slip that in there. But in the first one, what they did is they had this musical called Dragons versus Unicorns, which is why the book is called Dragons versus Unicorns. And Kate and Birdie go, and then there's like some problems that happen with the musical, and then there's something else that happens, and I don't want to give it away, but essentially they're able to use science to kind of come up with some solution. So it's a really fun one. And then the second one, oh my gosh, you guys, I can't even tell you how much fun this was to write. So for the second one here, it's called The Great Escape. And what it is an escape room with all science clues. But same thing type of happens here. They're like need to use science to save the day. Obviously, chemistry's the hero, and I just had so much fun writing that one. Again, I don't want to say too much because I don't want to give things away, and I'm so bad about that. I always spill the secrets. Okay, and then the third one, which is the one that just came out like a month ago, this is called The STEM Night Disaster. First of all, I want to be so happy, or I want to point out, because I love the orange color. Like, I absolutely love the orange. We were talking about different colors, but we landed on the orange, so orange. I just kind of wanted to add that there. That was a little kisses to the Longhorns there. But in the STEM Night Disaster, what happens is Kate and Birdie go out, and for the first time, they're going to have a STEM night in their school, in their elementary school. They've never had one before, but they get to now. And so they've come up with these different science projects, and then all of a sudden, somebody comes in and they're sabotaging Kate's project. And so that's what I'm going to do here is jump in and just tell you a little bit. I'm going to read a tiny bit about the story here for you. If you're in the younger age, what I want you to do is listen to the story and just enjoy it. Science into the story, right? Like, notice that I'm trying not to just like scream chemistry or scream these other words. I try to weave the science in to make it interesting. So I'm just going to read a tiny part because I know you guys want me to get to the experiments. Okay, so this is chapter 10. Title's called Something Really Up, and I start every single chapter with a quick definition. There's a science definition there, and then I've added behind it like some way to make it fun and interesting and exciting. So this one here is called electrochemistry. Now, electrochemistry is a noun, and it's a branch of chemistry dealing with metals. An electrochemist figured out how to make the coating on your sunglasses and the microchip in your computer. All right, so let's jump into the story. The next morning, Tuesday, I was skipping down the hall to class because last night I had figured out my Rube Goldberg machine. It was going to be so much fun to make. There was going to be stuff like a ramp, a pebble, dominoes, and Birdie's strawberry, of course. Now remember, Birdie is Kate's best friend, and the strawberry was just a gift that Birdie had given her a couple years ago, but it's very sentimental to Kate. It's very important. Kate's other best friend. So there's the 3 of them. They're really, really close. Wow, Kate, he called out. You're in a rush. Yep, I whirled around to wait for him. Then I explained to Elijah how I was going to put lemon batteries and the calculator into a Rube Goldberg machine. I thought about it all last night. I'm going to use a few lemons to power a little fan, which is chemistry and engineering, then blow a pebble down a ramp, which would be earth science and geology. Then pebble would knock into dominoes, which is physics, and the dominoes will push the strawberry, which is botany, you know, the study of plants, off. The spilled water will creep up the tissue paper that has been pulled tightly over a small vertical plastic arm. The water will force the Elijah. See you soon, said Mrs. Everlyn. Now I'm going to stop there. So Mrs. Everlyn is actually the character in the book that is Kate's 5th grade teacher. But Livia Everlyn in real life is a female scientist. Dedicated character on book after her in the 3rd book there. Okay, so now hopefully you'll notice that in the text when I was reading that to you, you'll notice how the science was like woven in there. I wasn't just screaming chemistry words. I was trying to like add it in there so it was easy to read. Still, we have a fun science story, but again, like it's about science and it's really entertaining and it's also fiction, right? Experiments. So every single one has an experiment, and I want to make sure that it's part of the story. So if you get to the end of the book, you will see how that particular experiment was used in the story. Again, I don't want to give anything away because I'm so bad about that. So what I'm going to do now is jump over to the other book. So my other book, this is the book that I wanted to do when I was a kid. Like, I was a reader, don't get me wrong, but I was someone who wanted to take things apart and put them together. And so that's why I wrote the Big Book of Experiments. And so the Big Book of Experiments is 25 experiments you can do at home with stuff that you probably already have in your pantry. Now, what I'm going to do right now is show you some of these experiments because I think that is fun. If you guys were on campus with me, we would be doing experiments together in huge explosions, but that's not available for us today. So today what I'm going to do is just show you some at-home things that you could possibly do. So make a list of these materials if you don't have them at home, but I will show you some alternatives as well. And I also have one little finale thing because I couldn't help myself. Okay, so let's go ahead and get started. So the first one I have for you guys is called the bubble snake. Okay, so let me get all my materials over here. So now the bubble snake is very, very simple. Okay, all you need is a bowl. Okay, you'll also need a spoon. You will need a plastic bottle. So now you'll notice that my plastic bottle here has a mouthpiece, and then it has about 2 or 3 inches here. I've gone through and actually chopped the end part of my plastic bottle off. You could keep it longer if you want to. You can add those extra pieces, but really you only need the mouthpiece and like 2 or 3 inches of plastic. So then what you will need is a rag. So you could use like a t-shirt or a sock, but you just don't want to use a paper towel. Okay, paper towels will disintegrate. If you want to see what happens if you use a paper towel, you can look up this segment of when I was on Kelly Clarkson's show because she used a paper towel and it did not work well for her. It was hysterical and she's a great sport about it, but I told her it wasn't going to work, but she had to try it. Anyway, all right, so then what we did is another solution, or what you also need is a solution of water and dish soap. So it's a 2-to-1 mixture. Today I'm using a 1/2 cup of water and a 1/4 cup of dish soap. And then the last thing I have here is some food coloring and then a rubber band. So like a hair tie, also glue, tape, anything like that would work. All right, so let's go ahead and get started. So we're going to go ahead and let's wrap our apparatus up first. So we're going to take our plastic bottle. Again, you need the mouthpiece and about 2 to 3 inches of the plastic. Then what you're going to do is take your rag. All I could think of was paper towel, and I was like, that's the one thing we don't want to do. So take your rag, t-shirt, sock, anything like that. Pop it over your plastic bottle like this. You're going to wrap your rag down. Grab your rubber band, and you're going to wrap your rubber band around the towel like this. I find that 2 times works really, really well for me. If I use 3 times, it crushes the container, so 2 is the way to go. Then we're going to put our apparatus aside for just a second. Now over here, you're going to take your 2-to-1 mixture of water to dish soap and pop it right into the bowl. Again, today I'm using a 1/2 cup of water and a 1/4 cup of dish soap. It doesn't really matter what kind of dish soap you use, but I would encourage you to use stuff that's not like the natural soap. So if you see something that's like natural, avoid that because usually what that means is it doesn't have a lot of surfactant in that. And surfactants are molecules that have a hydrophobic side and a hydrophilic side, and that's what helps us get a really bubbly, swooshy solution here. All right, so what we're going to do is stir this entire thing up. Otherwise, if you'll notice, the soap drops right to the bottom because it's a little bit more dense than the water. So we want to stir the whole thing together here to make sure that we have a soapy solution, a nice homogeneous solution. So I'm going to stir this just a little bit here. There we go. Mine was really thick. I really like Dawn dish soap. I don't want to say like names or anything like that. We're not sponsored or anything like that. I don't mean that. But I really like that dish soap. I think that's one of the best ones because it works extraordinarily well. It has really good bubbles, honestly. Okay, so now we're gonna grab our apparatus. You're flipping it upside down, so you've got your towel side up. You can grab your food coloring. So I have green, yellow, and red today. I have the chat open. There's the discussion open. If you guys have any colors or any votes you want, please just go ahead and pop them into the chat. Let me know what you guys want. I'll give you a second here if anybody's around and has a vote. So your options are green, red, or yellow. Any votes today? Let's see here. Oh, there we go. Anybody? No? Oh, there. Okay, I have to push show new. Okay, I wasn't using this properly. You have to push show new comment. I was hoping, the whole time I was like, I really hope this is live. I hope they can hear me. Okay, I cannot tell you how relieved I am. All right, so let's see here. We've got teal, green, and red. I see those. Green, red, blue, green. I don't have blue. Okay, that won't work. Red, 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 lots of reds. Okay, I'm seeing reds and greens, so let's do that. I am so relieved that you guys can hear me. This whole time I was thinking, if I am just doing a presentation to myself, I'm going to be so embarrassed. Okay, whew, so glad. What a relief. All right, so what I'm doing here is putting my green on here. I really like to do this in a stripe type of formation. As you'll notice, I'm running out of green food coloring, so I might have to use some more of a different color. That's okay. So I really like to do stripes. When I was on Kelly's show, she did spirals, little swirls. Again, it didn't work very well, but she had fun with it, so that's fine. So we'll do some red here. All right. Oh, it looks like I have the perfect amount of red and green food coloring today. We both ran out of both. That's awesome. All right, cool. So we've got some stripes here. Let me move this out of the way. Now what you're going to do is take your apparatus, you're going to flip it upside down like this, take your towel, dunk it right into your soapy solution, pop it right in, hold it up, it's going to drain. Your food coloring is going to drain. Let it drain into the bowl. Once it stops draining, take a deep breath in. And you make your bubble snake or an elephant snout trunk if you want to do that too. I kind of like that one, which I think is neat. Hopefully you guys can see the stripes too. The colors aren't that defined, but maybe you can see them today. I think you can see them down here. There's some reds and then some green stripes like that. Okay, so what we just did there is we pushed molecules out of our mouth. Oops, dropped my goggles. So we pushed molecules out of our mouth. So mostly when we exhale, we have nitrogen in there. There's also carbon dioxide. There's some oxygen, some water, some argon. There's a lot of different molecules that come out. And we have proof of that because we're pushing the molecules into that surfactant, which traps those gas molecules and exhales out into a really beautiful bubble snake, which I think is just awesome. Okay, so this is a very much a hands-on experiment. You can do this at home with pretty much any age group, but now I want to step it up a notch, just a little bit, okay? So let me get this out of the way. See if my bubble snake will travel with me today. Sometimes it does, sometimes it doesn't. Let's see if we can get it to behave. Come on, bubble snake. There we go. Beautiful. All right, so we're going to push this aside. Now what I'm going to do here is go ahead and pull my next demonstration up, which is my dry ice bubbles. I am so excited about this one. So what we need for our dry ice bubbles is a couple different pieces here. I'm going to show you a version of it, like what you can do at home, but you can also try a couple different things. You could maybe use a beaker, you could use maybe a vase, but again, I'm going to try to use a couple items that you could use, hopefully already have at home, honestly. All right, so you'll need that. You will need your funnel with a tube, which is bringing some bubble snake along today. No big deal. You're also going to need a bowl and some bubble bath solution. All right. And then I'm going to spike mine. You don't have to spike yours, but I'm going to spike mine. So I'm going to add some sodium hydroxide and some universal indicator. So before I do this, I'm going to put my gloves on. Okay, you'll notice that I'm wearing gloves. I've also got my lab coat on, so I want to be nice and safe here because I'm going to use a cryogenic here in just a second. So I've also got my goggles. I'm going to put my goggles on. You're going to be able to see my lights in there, but that's all right. So we'll put this up for just a second. All right, so the first thing we're going to do here is take your soda bottle. You've got it half filled with your water. Now what you're going to do is take your universal indicator. You do not have to do this part. You could use food coloring, you could use red cabbage juice, or you could just skip it completely. But I like to add universal indicator because it gives it a little bit of an extra like splash. Okay, so universal indicator is a solution that contains 5 different molecules. Now each of these molecules change colors based on the pH. So what you can see here is that I have kind of like a greenish color-ish what I'm going to do is spike it just a little bit with some sodium hydroxide. Let's see what color that gives us. Ooh, purple. Yes, I like that. That's good enough for me. All right, so now for the fun part, let me actually push this part to the side. I think you guys have seen enough of the books, right? Let's get the books out of here. Okay, so I got some dry ice. And so what dry ice is solid carbon dioxide. Now, dry ice is very, very cold, so I'm not actually going to touch it with my hands here. I also have some cryogenic gloves right here that I'm going to use to put the dry ice into my soda bottle. Now, my cryogenic gloves are really thick. They're very insulated. They protect me against that very, very cold species. So now I've got my dry ice, right? Solid carbon dioxide. We exhale gaseous carbon dioxide. So I'm going to go ahead and put these pieces of dry ice in here. There we go. Let me bring it up here right in front of the camera so you guys can see that. Pay attention to the color, because right now what we see is a beautiful purple. Okay. I'm going to add a little bit more dry ice. Pay attention to that color. Pay attention. Here we go. Purple still. Keep watching. Now we've got another green color. Ooh, keep watching. Keep watching. And there's yellow. Oh, I love it. I love it. I love it. Okay, so like what just happened there, right? So we have this thing called dry ice. Now, dry ice is solid carbon dioxide, or CO2. As it goes into the water, it turns into carbonic acid and it drops the pH of our solution. So we started off with that purple color. Purple is basic, so has a pH greater than 7. Then we got to that like blue and green color, which is neutral, so has a pH of 7. Then we ended up with this solution right here, which is that like beautiful yellow color. This is slightly acidic, so has a pH less than 7. Now, those different colors, that solution that I added, that indicator, that's what's actually allowing for those color changes to occur. All those different molecules that were in the universal indicator are going through and like indicating or telling us what the pH is of our solution. Now you'll see that I'm adding a little bit more dry ice because I want to go on to the next step, which I think is awesome. Okay, so here, what we're going to do is take this gas, this carbon dioxide gas that's coming out of the top, and we're going to redirect it. So I'm screwing on a tube that is connected to a funnel. And so you can see we're pushing the gas out here. And then what I'm going to do is redirect it into this bowl that I have some bubble bath solution in. And so hopefully, let me put that down, I can trap it in the bubble bath solution. And then we release some gas. Isn't that amazing? Oh, here we go. Come on. And sometimes if I'm lucky, send me your good vibes, guys. Sometimes I can catch it. Oh, so close. So close. Okay, let me try again. Let's see. Ooh. Ooh. That counts. That counts. Okay, let's see if I can do it. Oh, so close. So what we're seeing here is our dry ice is subliming. So it's going from the solid state, carbon dioxide solid, and it's turning into that gas. But it's going directly from solid to gas. We never see it turn into a liquid. This is a physical change, whereas that color change we were seeing in the inside, which, oh my gosh, guys, look, it's orange now. So when it went from that purple to the blue-green down to that yellow and orange, that's a chemical change because we're changing the pH. Isn't that one cool? So this one is also in that book, The Dry Ice Experiment, or The Dry Ice Experiments, the Big Book of Experiments. Oh my gosh, you guys, I just got tongue-tied. The dry ice bubbles is also in the Big Book of Experiments. Woo, there we go. But I didn't add the universal indicator or the sodium hydroxide because I wanted to make sure you could just do this at home. So all you would need for that would be to just use your dish soap. You would need dry ice, which you can get pretty much at any local grocery store. H-E-B has it. I don't want to tell you which one I go to because I want to make sure the dry ice is always there when I need it. But you only need your bubble bath and then that apparatus and then water. But you could completely skip that first part where you have the color changes. Okay, so now I want to do something that's not in any of the books. I want to do a little bit of a bigger experiment here just because, right, like it's girl day. We used to do huge explosions on campus. Remember, we'd have like at least 500 people in a room. It was so much fun. I'm really, really hoping that next year we can be in person. I think we can, don't you guys? I think so. I hope so. I hope so. I hope so. So what I'm going to do now is get prepped for my big finale, okay? So what I need for this one is this big red container. Now, this is an insulated container, and that's going to be used so that I can put something in it that's actually really, really cold, and I want to keep it cold. But what I'm going to need are some gloves, first of all. So let me get my gloves back on. And then going to need my cryogenic gloves. Here's one. There's the other. Fall off the table. Okay. Getting ready. Okay. And then I'm going to get my second cryogenic. So I was using dry ice before. This time, we're going to use liquid nitrogen. Oh. So liquid nitrogen is extraordinarily cold. It's 77 Kelvin or negative 196 Celsius. You'll notice that I have my cryogenic gloves on because that is the only way I would want to touch something like this. But right before I do this experiment, for no reason whatsoever, I'm just going to take this tarp really quickly and put it over my computer that's right here. Okay, there we go. All right, so my liquid nitrogen is really, really cold. And what I have down here below my feet is a really hot water heater. So the water is at about 80 degrees Celsius. It's not quite boiling. Boiling would be 100 degrees Celsius. This water is closer to 80. And so now what I'm going to do is show you really quickly a very small physical change. We saw sublimation before with the dry ice. Now what I'm going to do is show you vaporization. So for vaporization, what we're going to do is take a liquid nitrogen, and turn it into a gas. Okay, so you can do this very simply, right? And isn't that cool though? Okay, so you do this really simple reaction where we take this thermal energy from our hot water and we pour it into the liquid nitrogen. So the thermal energy allows for the liquid nitrogen to go from the liquid state into the gaseous state. So I can add more. But what I want to do is a really cool finale for you guys because I want to make sure we have a couple minutes to ask questions here. So I'm going to grab a little bit more water. Okay, I'm going to refill the first one because I want this to be big. All right. So what I have now, 2 big things of water, some liquid nitrogen. Let's see if we can have a big explosion here for the end of Girl Day here for my performance at least. All right, here we go. 3, 2, 1. Oh my goodness. Oh, I love it! What an incredible physical change. So what we have is here the liquid, the water was able to go into the liquid nitrogen. The liquid nitrogen was able to vaporize and go from the liquid state to the gas state, which you can see right here. Hopefully you can hear it too. Oh my goodness, you guys, it has been such a pleasure doing a virtual presentation for you all. I've had so much fun. Hopefully you all have been able to hear me and see me this whole time. This was my first time using this platform, so I really appreciate your patience with me as I got started. But thank you very much. If you want to know more, you can check out my website, katethechemist.com. You can follow me on Instagram at katethechemist. I'm on TikTok now, you guys. I can't believe it. But if you want to see what I'm doing on TikTok, again, at katethechemist. But I'm going to stick around and answer some questions. So please use the discussion here to submit any questions. Sorry, I just heard the comment from Jennifer that says my dad said you should have disappeared. I should do that. I should add the hot water and then just like disappear out of it. That would be a great finale. I love it. Great idea, Dad, from Jennifer. I love it. So what I'll do is take some questions here. So go ahead and submit them into the discussion. I have a couple minutes here. I think I'm only supposed to go 30 minutes, but I'm going to go over because I always do. So submit the questions in the discussion, and we'll go ahead and answer them. All right, so I see one from Jan. Is it safe to inhale the gas? Yeah, it absolutely is. The issue is there's no oxygen in it. So when I've done this before where I really hit it with water and the entire room fills up, in that case, I do actually struggle to breathe because this is a mixture of water vapor, it's nitrogen gas. Those are the primary 2 things, and you can breathe them. I'm breathing nitrogen and water right now constantly, but the oxygen is what I need to actually breathe and survive. I would definitely say that yes, you can inhale it, but you're going to need to make sure there's oxygen somewhere there so you can, continue living. All right, let's see. What else? Oh, I see. Oh, Amber, thank you so much. I really appreciate it. You guys are so sweet. Kristen, hi. I'm glad you loved it. Hema, oh, thank you. I'm glad you thought it was cool. Michelle, you have the book? Oh, yes, Hook 'em Horns, Michelle. I love these books. If I see you at any of these signings, all my book tours have been canceled because of the pandemic, but if we do a signing anytime soon, I'll make sure to post it online so we can meet. That is my least favorite part about this. I mean, don't get me wrong, I love virtual presentations. I love being able to connect with people all across the country, but I just miss interacting with students and talking to them and hearing their side of the story instead of just talking about myself and showing my side of things. Let's see, what other questions are coming in? Lots of votes for colors. Oh my goodness, so many votes for colors. I'm glad I got red and green in there. That seems to be the favorites. Lots of red vote. Oh, wonderful. I get a lot of blue votes usually, but I'm completely out of blue food coloring, which is kind of funny. All right, let's see here. What other questions? I just refreshed the page. 4-year-old Julia loved the explosion. Hi, Julia. Hi, Fernanda. Hi, everyone. I'm glad you love the explosion. I did too. It's so fun. What a great way to kind of start your Sunday morning. I'm going to go outside after this and go rollerblading. What a good day for explosions and having fun. What would happen if the liquid nitrogen was a different color? So it's really hard because what happens is the food coloring itself that we would probably try to use to dye the color, if you will, doesn't necessarily dissolve into liquid nitrogen. It does dissolve in water though. So what we can do is take dish soap and put it into the water itself and put the food coloring into the water, and we can kind of fake the color of the cloud, if you will, because the food coloring itself is going to stay with the water, and that goes to the bottom. And I can try to turn this a little bit so you guys can see at the bottom here. I've got liquid water. This is all liquid water. The nitrogen is completely gone, and I've got ice here. So this part would have all of that color. But if I use the soap can kind of trap the gas and shoot out. And just in the same way where my bubble snake kind of was a little bit red and green, we would be able to have a little bit of a colorful thundercloud. So it's not great. I've tried it before, but it still works. But it's not amazing. Let's see, what other questions here? What other questions? For the bubble snake, do you think it would work with natural dish soap? Okay, so Jamie, not as well. So natural dish soaps don't have the high of a concentration of your surfactants, and the surfactants are what makes the bubbles, and the bubbles trap the gas. So the natural dish soaps usually don't work very well. I really like Dawn dish soap because it's super bubbly. If you have bubble bath solution, that would work really, really well, and you would probably just be able to use it concentrated, dip it straight into the bubble bath solution, get it out of there though, because the color is going to drain in and ruin your bubble bath solution, but you should be able to use it without diluting it very much. Can you freeze one of the leaves from the plant behind you and show us how it shatters from being dipped in liquid nitrogen? So it's a fake plant, so it wouldn't work very well, but I love that idea. Maybe I'll have to do that for my next presentation, next Girl Day. If Barry is on here, Trisha Barry, remind me to do that so that we can do that next year, because that's really funny. Okay, Alex asked, could you make a bigger explosion? Yes, the only thing is that the gas would come up all the way here and it stays in this room. I shared a video, I think it was on TikTok, maybe it's on Instagram, but I showed you how the gas actually sits in this room really, really high. And because I have this Q&A right now, I had to make sure it only sat at hip level. I should have shown you guys the bottom. If I had moved the camera, you would have seen that the gas was staying right at hip level there. And so if I had dropped down, I would have had trouble breathing. So it depends on if I have a Q&A, how big the explosion is. All right, what else? Thank you, Kelly P. This is amazing. Thank you. A flower explosion. Abby, I agree with Rob. You should read the books. They're very, very fun. The fiction books are so much fun to write. As you guys probably know, I'm a scientist, so I always have to be completely 100% accurate. And so it was really, really fun to get creative with the fiction stories and let my mind wander and just kind of make stuff up, because you cannot do that in chemistry. So that was really nice to be able to get creative. And this is just kind of totally unrelated, but my mind just thought of it. So in May, I'm coming out with a follow-up book to the Big Book of Experiments, and it's 25 experiments you can eat. So the book is called The Awesome Book of Edible Experiments, or for kids, I think it's at the end. And it's 25 experiments you can eat. And so last May, during the pandemic, when things were just awful here in Texas, I essentially locked myself in my house for 3 weeks, opened up my pantry, and just made 25 experiments based on what I had in my pantry. So in the book, I show you guys how to make ice cream. I show you what the difference is between baking soda and baking powder. I show you how to make fried eggs. I show you how to make a smoothie properly. So all these different things, because when you're in a kitchen, you're actually cooking. Like every time you're in the kitchen, like it or not, you are being a scientist. So that's one of the things that I love about that book. So that's coming out in May, guys, if you're interested in that. What was the best experiment you've ever had? And this rocked today. We'll be getting some books soon. Thank you, Jennifer. Oh, you're so sweet. The best experiment. Okay, so I love fire. So I'm definitely a fire girl. I really like to do hand on fire, where you do something. I was going to say similar, but the only thing similar is you need a bucket. That's the only thing similar. So you take a bucket, you fill it with water, and you dunk your hand in the water. You completely cover it with water. Water has a very high specific heat capacity. And so what that means is it takes a lot of heat to raise the temperature by 1 degree Celsius. So water essentially acts as another safety jacket for you, or a lab jacket. So what I do is I dunk my hand in the water, completely cover it. I go over to another bucket, dunk my hand in there. In that bucket, it is filled with bubbles that I've injected with methane gas. So I can then pick up the methane gas. So it's a bubbles. Just think of big bubbles, but the bubbles inside, instead of like my exhale that's trapped like we did the bubble snake, instead it's filled with methane gas. And so that is extraordinarily flammable. And so I can have my hand really far out, and then I have someone else, like my assistant, come and they light me on fire. So that's really, really fun. I got to do that one yesterday for the first time. No, sorry, I got to do it Friday for the first time in about 1.5 years. And I was like so excited, you guys. I can't tell you, I'm a little kid in the candy store, except for me as a scientist with fire. But one thing, do not play with fire unless you are a trained professional. I have a pyrotechnic certificate. Like I've been through all the trainings. Like you need to be really careful, and you need to make sure you know exactly what you're doing, and you always have the proper equipment. Okay. All right. Let's see here. Great questions, you guys. Thank you. Will the bubble snake work with the liquid that comes in the kids' bubble wands? It should. It should. That would be a great experiment. As a scientist, you should try it. See if it works. See if you need to spike it, if you will, like add just a couple squirts of dish soap to it. But I wouldn't think you would need too much more. Ooh, I saw Go Blue. Ah, yes. University of Michigan fan in the house. Go Blue, Rob. I love it. Do you have any more events coming up? Yes, tomorrow I'm going to be on a Women in STEM panel event, but that is my last event planned for at least a week. I'm trying to get better about posting on social media when I have future events. I know I'm so bad about that. I apologize, guys, but I'm trying to get better. I have 2 social media interns who are helping me, so we're getting there. But I would say I actually don't know when my next live performance is like this. I'm going to try on Instagram to be doing more experiments live, just like single experiments one at a time, like in the weekend. So if you guys just want like a Saturday morning activity, but send me requests. If you have ideas of what you want or things I can do, please let me know. I want to connect with you as much as possible. I cannot tell you how much I miss actually talking to humans. So if you've got an idea of something you think that would be great, please reach out to me. Let's see here. Would the bucket freeze from the liquid nitrogen? So this one does not, but when I have a, how do I have it in here? Like a painter's bucket, like one of those Home Depot buckets that you always see, those cheapo buckets, those don't freeze necessarily, but they're completely covered in ice. So I always make sure I use something like that because it doesn't crack. I've been on TV shows where they've tried to get me to use a glass container, and I'm like, not happening, because that cracks. There was something else they tried to use one time, and I was like, it's not going to work. It's not going to work. They're like, it's going to work. I was like, it's not going to work. And so I stepped back, and somebody else who had training, they were properly covered, poured it on this it was this big porcelain, if you will, like, what was it? I can't remember what it was made of. It was something weird, but it was this big bowl they wanted me to use. And the second the liquid nitrogen touched it, it cracked in half, like right at the second it touched it. I'll never forget that. So it's definitely something that's very, very cold. You want to make sure you use cryogenic gloves when you play with it. You shouldn't play with it, to be honest. And you'll always need to use a container like this. You'll notice that I actually use the lid here at the bottom for my container. I will never put just the bucket itself of liquid nitrogen on the table because it's so cold that it will kind of like seal to the table itself. It gets stuck. Same thing with my dry ice. If you notice when I pulled it up here, I have a t-shirt or a towel or something that I always put at the bottom because otherwise it will stick to my floor. And so this way I can pull it up. The towel or the shirt comes with it, but at least it doesn't stick to the floor. Where can you get my books? Oh, thank you, Jennifer, for asking. You can get my books anywhere books are sold. So they're sold on Amazon, Barnes & Noble, all of our local bookstores. Please support your local bookstores. I'm a big fan of that. But yeah, you can get them anywhere where books are sold. You can find them on my website too. How do you breathe fire? It's really easy. You take a substance that you put in your mouth that is flammable, that I'm not going to tell you what it is because I don't know how old you are yet. And then what you do is you breathe it over a propane torch. You take one deep breath and then just straight over the torch, and then you shoot fire out of your mouth, and then you use water to rinse it all out. And it's really, really easy, but you need to be a trained professional and be trained by somebody who knows what they're doing before you ever do that. So I'm not going to tell you what it is, but it's really easy to do once you know how to do it properly. All right. Are there nitrogen clouds on Mars? Ooh, you know, I actually do not know what the composition of the atmosphere is on Mars. I don't believe there are nitrogen clouds there, but we are going to have to get some of our astronomy buddies in to do that. But I don't know. I'm a chemist here on Earth. That's where I stick to. What was one of the worst experiments that backfired? Oh, Michelle, that's a hilarious question. Okay, so I will have to say something where I got hurt. I've done an experiment where I was trying to get a cool picture. My first year on the job, I was lighting something on fire, and I was like, oh, I'm going to take my lab coat off. Like, I can do it. And it was so stupid. I shouldn't have done that. The fire traveled right up my arm. It burned my arm. Thankfully, I have hair on my arm, and the arm saved me. And then my buddy Eric was there, and he sprinted to me, and he covered me with burn cream immediately, so that helped me as well. But it was such a dumb mistake. Like, honestly, there's no other word for it, but it was a dumb mistake. Like, I took my lab coat off to try to get a cool picture. I will never do that again. You'll notice I always have my lab coat on. I'm always protected, and I usually have a long sleeve shirt on underneath it, so I've got double layers here as much as possible, even though it's really hot, but you just have to be safe. So you will not see me do that again. Could you cook a marshmallow with by breathing fire? Oh, that's brilliant. That's a TikTok video I should do. Huh. I love that idea. I really love that idea. Okay, I'm going to have to try that. You'll see that on TikTok in the next couple of weeks because I think that's hilarious. Okay, my mom wants to know if you do summer camps. I used to do summer camps every single summer. They were day camps here in Austin, and the last set I did was a 4-day because I would build up to it. So the first year I did 1 day, the second year I did 2 days, and the last one I did had 4 days. But that was pre-pandemic, and so I haven't done anything since then. I am very, very scared of COVID. My husband is high risk, so I've been essentially isolated in my house completely. I wear double masks if I'm outside. Like, yeah, so I don't see me doing summer camps this summer, maybe something virtually. I will say that I support in like every way possible Girls Start. It's an incredible organization here in Austin. I am a big, big, big supporter of them. I support them every time I possibly can. I donate time, money, everything for that group. And they do virtual STEM camps, so they send out boxes to kids. Last year I partnered with my friend, and we were able to raise enough for 38 girls to go to virtual STEM camp. It was his 38th birthday, so we were trying to send 38 girls to virtual STEM camp. So I highly recommend Girl Start if you're looking for an organization to support. They do good things with your money, and it feels good. So I like that one. And you can also volunteer, but I haven't been volunteering with that group. I've been staying at home until this is over. We're almost over, though. We're almost done with the pandemic, guys. We're getting there. And I think that's it. I don't know. I think let me see. I'm going to glance through here to see if I missed any other questions. But I think that was everybody. Y'all, thank you guys so much. I really appreciate you for showing up, for attending this. I hope you keep bouncing around and doing all the other events that they put together for Girl Day. What an incredible, incredible event. Shout out to Trisha Berry for doing everything she did. I mean, I just can't even, like, she's just an incredible woman. So if you're friends with her or you know her at all, please give a big shout out to her because this is just incredible. So I'm going to try to sign off here. I don't know if I'm going to do this properly, so please don't make fun of me if I hang out here for a few minutes poking buttons. But I just want to say goodbye to everybody. Thank you so much for showing up. And of course, hook 'em horns. Bye, y'all.